In this tutorial, we're going to look at how to select a machine for use with Mastercam. This is a pretty straightforward process, and it can be achieved by going to the Machine tab of the ribbon. From the Machine tab, you'll notice that the first section here is called Machine Type. From Machine Type, we can select what type of machine we want to program for. In this course, we will be considering CNC milling and how to use a number of basic toolpaths associated with that. So to select the CNC mill, we're going to click on the drop-down, select Default, and you'll notice that the Toolpaths panel in your side panel will now be populated with a couple of new settings. Each of these will be considered in a following tutorial. In this tutorial, we'll look at tool settings. Tool settings are one of the submenus of the Properties menu, which is itself a submenu of the active machine group. If we click on Tool Settings, you'll notice that we're presented with a new window with several options in it. Let's take a moment to look through each of these. The first thing we have on the left-hand side is the default program number. This can be adjusted to whatever we desire for the program number. Feed calculation is a calculation that Mastercam uses to determine the feed that a particular tool should run at. This value can be set to a tool, which is done primarily with pre-constructed tool libraries. It can be set from a material, which is, there's a number of these done by default through Mastercam's own software. And then from defaults or user-defined, which are set in different ways. But the main two that are used would be these top two. Some other things to note here in the toolpath configuration section. Throughout any toolpathing projects in this course, there's a number of things here you'll want to enable, and I'll explain briefly what they do. We generally want to assign tool numbers sequentially. This is because within Mastercam's tool library, every tool has a dedicated number, but these numbers range from 1 to several hundred, and for the purpose of clarity and programming this to actually be run on a machine, rather than calling up a tool number into the hundreds, this will just assign a new tool number based on the order that you add it to the program in. The second setting here as well is good to enable warn of duplicate tool numbers. So if we accidentally end up with two tools with the same number, this will give us a warning. That way we don't accidentally crash the machine or something of that nature. These next two settings we don't generally use. They're a little bit more advanced. In the Advanced Options section, there is a number of features here we do enable. Override defaults with modal values. This allows when we make changes to certain features of tools in Mastercam when configuring toolpaths, it carries over our changes between each toolpath we create rather than resetting it to the default each time. This helps save time and helps auto-populate certain fields that are likely to be repeated between toolpaths. Then, of course, you get some of the options of what can be carried over, and we want to check all of these: clearance height, retract height, and feed plane. Sequence number refers to the code blocks when you actually post the program. So this is basically asking what line of code you want to start programming on and what increment you want to move from there on. So with this current default setting, Mastercam will output its code file starting on line 100, and then it will only insert a line of code every 10 lines. This is done to allow for modification and easy manipulation of the code after post. If you use a starting line of 1 and increments of 1, there won't be any space between lines to add any details in if that's ever need to be done after the fact, and that does happen from time to time, so it's nice to have that buffer. Finally, at the bottom we have our material selection. Now this is especially relevant if we were using the from material feed calculation we talked about at the top here. When we click on select, you'll notice here the only material listed is aluminum millimeter 2024. Of course, that's the mix of aluminum. If we come down here, we can look, there is inch libraries as well as millimeter libraries, and we can click here where it says source to see some other options. So currently we're on the mill current, so the currently loaded materials. If we instead go to the mill library, we can see there's a number of different materials that we can pick from here, many, if not all of which, have custom feed values for them in order to efficiently machine them. So there's a few different mixtures of aluminum, many other materials, coppers, irons, magnesiums, plastics, steels, even wood. So there's a lot to pick from here. Most commonly for projects when we're strictly working in Mastercam, we will work with an aluminum variety of some kind, either 2024 or 6061 usually. Of course, if you were actually machining a part that you make in Mastercam, it would be wise to use the correct material, and if it's not present here, you can always add a custom material with the details you would get from the manufacturer of that product. So for this case, we'll leave it with 2024 aluminum. We'll say OK, and you'll notice that that stays in this field here. That about wraps up our tool settings tutorial. Just keep in mind with the projects you're going to be doing in this course, please remember to enable the first two checkboxes in Toolpath configuration and all of the checkboxes under advanced options. That concludes this tutorial. In this tutorial, we will look at stock setup, which is another submenu under the Properties section of Machine Group. Stock setup allows us to adjust the programmed size of material that we're working with within Mastercam. This is especially important if we were actually machining the object on a CNC machine. For the cases of this course, you will be given direction on what your stock size should be, and if you are not given direction on it, then you will assume that it's the minimum size required to machine the part, which can be attained in a few ways. In this menu here, there's a number of settings we can look at. Primarily the shape of the stock we're working with, whether it would be cylindrical or rectangular. If you choose cylindrical, you can choose the axes that it will be positioned in. Most commonly we're working with rectangular. You'll notice here there's a toggle to display the stock. This is often helpful to see a wireframe outline of where the stock exists so that we can ensure that we're working within those boundaries correctly. We can enable that by checking it. And then over here we can adjust our actual stock sizing. So if we already know the size of our stock, we can enter the values here. Perhaps it's 4 inches by 4 inches, or we're actually in metric, so that would be 4 millimeters by 4 millimeters. And then in Z, whatever the case would be there. So we can enter our values here, and then the stock origin allows us to adjust where we would actually have our 0 be located if we were to machine this part. So this point can actually be selected. You can click on any point of the stock model, any of the corners or the center, in order to set that as your datum. Generally we work with the center or the bottom left corner primarily. Both of the projects within this course will be working from the center. So when you select the center like this, you can enter your stock values here and press OK to continue. A couple quick notes, however. If we were to create just quickly an object, perhaps we'll use a block as an example. If we create a block, rotate my view to make it 3D here. Okay, we have a simple cube. I'll say OK. If I go back into stock setup, there's actually another setting here that's very useful, especially to quickly determine a stock size. If your stock is approximately the same size as the part you're going to be creating, then selecting the All Entities button here allows you to automatically create a stock boundary that encompasses the object you've drawn. You'll notice here that it punches in the exact values for each dimension of this block I've created. Commonly, we will increase these values slightly in order to allow for some machining to clean up the outside. Perhaps increasing this to 22, this one perhaps to 25, let's say, and maybe this one to 20. Of course, this will vary depending on your actual stock size and what you're working with, but for illustration's sake, we can type in values such as these. And then the stock origin coordinates is also a useful thing to be aware of. This allows us to select where we want the stock to be centered on. If I was to click OK right now, you'll notice that the stock boundaries, the red dotted line, automatically balances itself on either side of the object in both the y and the x axes. However, it does not do so for the z axes. You'll notice that all of the excess stock, the blank space inside the red dotted cube, is at the bottom of the material. Now this is fine if you are not intending to face the part, but if you are planning to face the part, you generally want to leave some stock allowance to do so. To correct for that, we can go back to the stock setup and adjust our stock origin in Z. If we increase the location of our stock origin by increasing this value to, say, 19 and press enter, you will notice that back in our stock view, the allowed stock around the part has now spaced to be more equally above and below the part. This is how we would adjust to make sure we have stock available on all sides to machine this object out of it. That about concludes our stock setup tutorial. There are a few other options at the bottom here for selecting objects on screen, but most often we will just use all entities and then adjust these values slightly if needed. In this tutorial, we will begin considering chaining within Mastercam. We'll start by looking at 2D wireframe chaining. We can examine that by starting by creating some wireframe geometry. To do that, I'm just going to create a rectangle here on the screen, and we'll use this rectangle to illustrate the different methods of chaining that are available within Mastercam. I've thickened the line a little bit, so hopefully it's easy to see. And the next step is to select a toolpath. Now the toolpath I select doesn't really matter all that much, and we'll discuss each one in detail a little bit later. But for now, I'm just going to select this one called Contour so that I can get the wireframe chaining dialog box to appear. This dialog box shows us all the different settings and options we have to use with chaining. The three we're going to consider in the wireframe chaining mode are the chain, partial chain, and window chain selection options. The standard chain selection method allows us to select one line of an object, of a wireframe object I should say, and it will automatically attempt to select any adjoining wireframes to create a loop. You can see because this is a continuous shape, it was able to successfully select all four sides of the rectangle back to the starting point. This is an example of a successful chain. Another method of chaining is the partial chain method. If I click the deselect button right here, what I can do is activate partial chaining. And how the partial chaining works is you select your starting point, like with normal chain method, but then you can individually select the end point as well. So I've selected here to be the start point. I'm going to select this line to be the end point. You'll notice it looked for a route between those 2 points and connected them. But unlike the original chaining method, it did not create a complete loop. Depending on the toolpath you are using and your desired result, this is an important thing to be aware of, that you do not have to create complete loops when chaining. If I deselect this again, the one final method we'll look at quickly is the window selection method. When window selection is enabled, you can drag a box around wireframes just like you can any other time you're selecting geometry in Mastercam. When you do this, you'll notice it appears as nothing's happened at first, but you'll notice we have a new prompt here that says sketch approximate start point. It's already recognized that this entire wireframe is what we want to chain, as I drew a box around it. However, now it wants to know approximately where do we want the tool to start cutting from. If I choose the top left corner, you'll notice when I click it, it does select the arrow from that position in a loop. This particular selection method is very useful if you have a lot of small chains that are difficult to select individually, like in the case of doing engraving for letters or something else that's fine detail. That concludes wireframe chaining, and we'll be using these throughout the course. In this tutorial, we'll talk about cutting direction inside. This is most easily represented by just chaining a simple rectangle. I've created a rectangle. I'm going to go to the Toolpaths tab now and select Contour, again just relatively arbitrarily. And what I'm going to do is select this rectangle here. Wherever I select this rectangle brings up a couple of key points of note. When chaining in Mastercam, there are two ways you can chain any feature. You can chain clockwise or counterclockwise. The way you determine this while chaining is affected by where on a line you click. Whatever side of a line you click on, it will always create an arrow facing away from that closest corner. If I click on this side, the green arrow faces to the left. If I click on this side, the green arrow faces to the right. This is important because when we are milling an external feature, it's usually best to chain in a clockwise direction. And when we're chaining an internal feature, we generally want to chain in a counterclockwise direction. The reason for this is that on standard machines, we would be cutting with right-hand tooling, rotating the tool rotating clockwise, like this. As the tool comes along beside a part, if it's traveling in this direction, it's going to be doing what would be considered conventional milling. Conventional milling has a few downsides, one of which being that it has a tendency to pull the tool into the work. This can result in incorrect sizes, resulting in failed tolerances and scrapped parts. While this is not always a problem, and it greatly depends on the rigidity of your machine and the type of cut you're attempting to make, generally, climb milling, the opposite of conventional milling, is usually preferable, and there's actually a number of reasons why that's the case. Climb milling has a number of benefits. For one thing, it reduces the load on the cutting edge, it creates a better surface finish, and it improves the life of your tools. Most of these things are relevant when we're actually manufacturing products, but it is very good to get in the habit of these practices right away so that we can continue that into manufacturing. So just as a quick reminder, if we imagine the tool turning, remember that our tools are going to turn in a clockwise direction, so we can move our mouse in a clockwise direction, and our goal is to have the tool always climb milling around a feature. So when we're cutting the outside of a part, that would mean we want to travel around the part clockwise, because the cutter, as it comes around, it's grabbing into the material on the leading edge like this. If you picture that, the reason why it's called climb milling is it's climbing up the material as it rotates into it. The difference being conventional milling, where you're catching the material on the back edge of the tool every time you come in for a cut, inherently pulling the cutter into the material instead of pushing away from the material. For these reasons, climb milling is generally preferred for most applications, so try to always be sure that your arrows are traveling in the right direction. The reason why we say internal features are reversed, of course, is because if you picture machining on the opposite side of this line, the tool, of course, still turning in a clockwise direction, in order to maintain a climb mill, you actually need to travel the other direction, this way. So if this was an internal pocket we were machining, this would be the correct chaining direction to get a climb mill out of that. However, if this was an external feature, like milling around the outside of a block, we would want to chain the other direction. In order to do that, there's actually a quick button here for reverse direction. When we click this, you'll notice the arrow now points the other direction from that corner, going up. And again, if we picture our tool rotating in a clockwise direction, we are now achieving that climb mill method we are looking for. If we press OK, there's one quick final method that we can use to determine if we have chained correctly. And once we've created a toolpath, which again, we'll look at this in a lot more detail in an upcoming tutorial, but if we click on the geometry option here, underneath the toolpath in question, we'll be presented with any chains that were selected in the creation of this geometry. Now, you'll notice in this case we only have one chain. However, once we're in this menu, our chain has an extra detail. And that is, we have the standard arrow we started with, but we also have this little arrow here, this outward facing arrow. This part of the arrow represents the cutting side. So we have a direction of chain, that's the main arrow. The smaller arrow represents the side that the material is being cut on. And again, this will be automatically swapped depending on whether we're cutting inside or outside a feature. Mastercam will always try to climb mill by default. So if we were to change the direction of this arrow by saying reverse, or rather change side, sorry. If we hit change side, you'll notice now the arrow is pointing into the part. This actually means now that if we tried to cut this feature, the tooling is going to come in from this side, resulting in an internal feature, not an external one. So just a quick little note for troubleshooting if you do run into any problems with the machining or chaining side as well as direction. If you can keep these points in mind, then this will help you a lot moving forward in this course. In this tutorial, we'll talk about process planning. Process planning is a very important step of programming and modeling in Mastercam, specifically when you get to the toolpathing stage. The reason that it's so important is that because without this step, you're likely to cause much more problems for a machine operator than you will solve problems for them. There's a lot of things we have to take into account when creating an actual program to cut a piece of material. And a lot of these things will be things you may already think of if you have any kind of background in machining or manufacturing to begin with. Some things to consider. Work holding, for example. Ask yourself questions like, how am I going to hold this in a machine? Or how will an operator set this up in a machine? If we cut the features in a particular order of this part, will it still be able to be held safely or effectively? Do we need to leave additional stock in our program so that the part can be held properly? What about tool selection? What tools are actually available in the shop where this is going to be produced? We may have access to the tool library in Mastercam, but does our shop actually have a 6-inch face mill? Maybe, maybe not. Do we have incremental imperial sized end mills by 30 seconds? Or by 16ths, or by 8ths? All these questions are good to consider to know what the most efficient tooling we can use is to machine features and still be realistic in our expectations here. Order of operations is a very important one. What is the most efficient order to machine the features of this part? Will my order of operations that I've selected interfere in any way with any of the other steps of process planning, such as work holding? If I machine a particular feature right away, am I still able to hold the part after? What about wasted tool movement? Think about how you can reduce the movement of tools as much as possible. Can you reorder your operations to allow the spindle to end up closer to where the next feature is to be machined, rather than on the other side of the part? These might seem like small things, but when you have a program that's thousands of lines of code long, which is easy to do with Mastercam very quickly, every little piece makes a big difference in the long run, potentially saving minutes or even hours off of your finished program. Another thing to keep in mind with tooling is how can you use the fewest number of tool changes possible? When we're working on CNC machines, we're always trying to save every little second we can to make programs more efficient, be able to run faster, and potentially make more money for our employers or ourselves, depending who we're working for. So little things like eliminating a tool change by using one tool for everything we need to use that tool for, all at the same time, is often preferable than tool changing several times back to tools we used previously. Sometimes this is not always possible, of course. If certain features are dependent on other features to be machined first, sometimes we do need to have redundant tool changes. But most of the time these can be eliminated with good process planning. Another thing to consider is our toolpath selection. As we'll learn in the coming tutorials, there's many different toolpaths within Mastercam, all designed for specific features. Am I using the best toolpaths I could be for this part? Perhaps, is there a toolpath I could use that would let me machine multiple features with one toolpath, possibly saving a good deal of time? Finally, what about our finishing technique? Am I going to need separate toolpaths for finishing the features of this part? How tight are my tolerances that I'm working with? Can I get away with just roughing cuts? Or do I need multiple finish cuts? Do I need spring passes? All of these things are things you need to take into account. Additionally, is there any extra tools you're going to need to get a good finish or to clean out a feature properly after a roughing tool goes through. It's often preferable to have the largest tool possible take your roughing cuts on a part. However, that's not always practical for finishing, as there's certain perhaps radiuses or pockets that you cannot clean out effectively with a very large tool. So these are all things to take into account with process planning. By reviewing these steps when you start a new project, especially when you get to the toolpathing stage, you'll save much time off your program, and you'll really set yourself apart from those who take less of a priority to process planning.